Welcome to my presentation on the personalized product recommendation system for e-commerce businesses. In this session, I will explore how machine learning can revolutionize e-commerce by delivering highly personalized product recommendations, enhancing user engagement, customer satisfaction, and revenue growth. Let's dive into how AI-driven recommendations can transform the shopping experience and drive business success. Now that I've introduced the topic, let's take a closer look at the core problem we aim to solve with machine learning-powered recommendations. E-commerce businesses often struggle with generic product recommendations that fail to engage customers, leading to lower conversion rates and lost revenue. Personalized recommendations address this issue by analyzing user behavior, purchase history, and browsing patterns to suggest products that are most relevant to each individual shopper. With machine learning, we can automate and scale this process, delivering real-time, data-driven recommendations that improve customer experience, boost engagement, and drive higher sales. This presents a powerful opportunity for e-commerce businesses to increase customer retention, maximize revenue, and create more personalized shopping experiences at scale. Now that we've identified the problem and opportunity, let's explore how we structure our approach to building an effective solution. To develop a scalable and high-performing recommendation system, we use the CRISPDM framework, a structured methodology for machine learning development. Business goal: our primary objective is to increase sales by 15% through personalized recommendations that improve customer engagement and conversions. Data understanding and preparation. We will analyze user demographics, purchase history, and browsing behavior to understand individual shopping preferences. We will collect and pre-process data from user interactions and product catalogs, ensuring compliance with privacy regulations such as GDPR and CCPA. Modeling. We will implement collaborative filtering and deep learning models to generate highly accurate, personalized recommendations. Evaluation metrics. Success will be measured using precision, recall, average order value, AOV, and click-through rate, CTR, to assess recommendation effectiveness. Deployment and continuous improvement. The system will be deployed in a cloud-based environment for scalability and real-time processing. We will implement continuous feedback loops, allowing the model to refine recommendations dynamically based on post-interaction user data. By following this structured approach, we ensure data-driven decision-making, compliance with privacy standards, and continuous optimization, ultimately driving higher engagement and revenue growth for e-commerce businesses. With our structured approach in place, the next step is to define how we measure success and ensure our recommendation system is delivering value. To evaluate the effectiveness of our model, we rely on key success metrics that provide insights into recommendation accuracy, user engagement, and business impact. Let's take a closer look at the 4 key metrics we will use to track and optimize performance. Precision measures how accurate our recommendations are by calculating the percentage of suggested products that users actually engage with or purchase. High precision ensures relevance and prevents unnecessary recommendations. Recall determines how many relevant products were successfully recommended compared to all possible relevant items. A high recall score means our system effectively captures user interests and doesn't miss key opportunities. Click-through rate indicates engagement levels, measuring the percentage of users who click on recommended products. A high click-through rate suggests that recommendations are compelling and drive user interactions. Average order value tracks the increase in spending per transaction, showing how well recommendations encourage users to add more or higher value products to their cart. Improving average order value means higher revenue per customer and better upsell opportunities. By continuously tracking and optimizing these metrics, we ensure our ML model remains accurate, engaging, and effective, directly contributing to higher sales, increased customer retention, and business growth. Now that I've outlined the key success metrics, let's see how these metrics apply in a real-world scenario. One industry where personalized recommendations have a significant impact is fashion e-commerce. By leveraging machine learning-driven recommendations, fashion retailers can increase average order value, improve customer retention, and enhance the overall shopping experience. Let's take a closer look at how this works in practice. By implementing machine learning-powered recommendations, fashion retailers can increase average order value, personalize suggestions, encourage customers to add complementary items to their cart, boosting upsell and cross-sell opportunities. Improve customer retention. Tailored recommendations keep customers engaged and coming back, increasing repeat purchases and brand loyalty. Enhance user experience. AI-driven personalization reduces friction in shopping, making it easier for customers to discover products they love without endless browsing. These measurable improvements demonstrate how machine learning-driven recommendations translate into tangible business growth, reinforcing why precision, recall, click-through rate, and average order value are critical success metrics. Now, let's talk about a solution validation plan. Iterative development and testing building. An effective recommendation system isn't just about developing a model. It's about continuously testing, refining, and optimizing its performance. To ensure that our personalized recommendations drive real user engagement and sales, we follow an iterative validation approach, starting with a baseline prototype and progressively enhancing it with more advanced models and real-world feedback. Let's take a look at how we validate and improve our recommendation system step by step. To ensure our recommendation system is effective, accurate, and continuously improving, we follow an iterative development and testing process that involves building an initial prototype, refining it with deep learning, and validating its performance through A/B testing. Collaborative filtering prototype. We start with a simple collaborative filtering model, leveraging user purchase history and ratings to identify similar users and recommend products they might enjoy. This serves as our baseline model for comparison, iterative improvement with deep learning models. Once the initial prototype is validated, we will enhance the system by integrating deep learning models. These models capture more complex user behavior patterns and product relationships, significantly improving recommendation accuracy and personalization. Conduct A/B testing for user feedback. To evaluate the real-world impact of our recommendations, we will conduct A/B testing, comparing different recommendation strategies against a control group. This allows us to measure key engagement metrics, user satisfaction, and conversion rates, ensuring that our model delivers measurable improvements. By following this data-driven, iterative approach, we ensure that our recommendation system remains accurate, responsive to user behavior, and continuously optimized to drive higher engagement and sales. Now let's talk about machine learning system design key architectural decisions. To ensure a scalable, efficient, and high-performing recommendation system, we made several key architectural decisions. 1. Cloud-based deployment. We chose a scalable cloud-based architecture to handle large volumes of user interactions, process recommendations in real time, and integrate seamlessly with the e-commerce platform via a recommendation API. 2. Online learning for continuous adaptation. Our system incorporates online learning, allowing it to adjust dynamically to changing user behavior and market trends, ensuring recommendations remain relevant. 3. Real-time predictions. To maximize user engagement, we generate online, real-time predictions, providing immediate and personalized recommendations while a customer browses. Fourth, continuous feedback loop. Post-recommendation user interactions are collected and analyzed to refine model accuracy, improve recommendations, and retrain the model regularly. By integrating these elements, our system delivers fast, adaptive, and highly personalized product recommendations, improving conversion rates and customer satisfaction. Now let's talk about potential risks in a live production environment. Key challenges in deploying our AI-powered recommendation system include training serving skew, data drift, latency issues, and bias in recommendations. Training serving skew occurs when the model performs well on training data, but struggles with real-world user interactions. Data drift happens when customer preferences and shopping trends change over time, making past data less relevant. Latency issues can slow down recommendations, negatively impacting user experience. Bias in recommendations may cause unfair product exposure, favoring certain brands or categories. To mitigate these risks, we will implement regular model monitoring, automated retraining, fairness audits, and infrastructure optimization to ensure fast, fair, and reliable recommendations for users. Now, let's talk about mitigation strategies to manage risk and ensure system robustness. To ensure our recommendation system remains accurate, fair, and efficient, we have implemented the following risk mitigation strategies. 1. Regular model retraining. Our system will be periodically retrained to adapt to changing user behaviors, trends, and new product data, preventing data drift and maintaining relevance. 2. Monitoring data patterns. We will continuously track shifts in user behavior, product preferences, and engagement trends to detect and address data drift and training serving skew before it affects recommendations. 3. Infrastructure optimization for speed. To ensure a seamless user experience, we'll optimize cloud-based infrastructure for low latency predictions, leveraging real-time processing and caching mechanisms to reduce response times. 4. Bias mitigation. We'll conduct fairness audits, balance training data, and diversify recommendations to prevent algorithmic bias, ensuring fair product exposure and equitable recommendations for all users. By proactively addressing these risks, we ensure our machine learning-driven recommendation system remains scalable, unbiased, and high-performing, ultimately driving trust, engagement, and revenue growth for e-commerce businesses. In summary, machine learning-driven recommendations enhance sales and user satisfaction by delivering personalized, data-driven experiences that adapt to individual preferences and behaviors. By leveraging machine learning, e-commerce businesses can achieve higher engagement, increased revenue, and improved customer loyalty. Additionally, machine learning helps mitigate risks through early, actionable predictions and continuous model improvement, ensuring reliable performance. Looking ahead, the next steps include building and validating the model, gathering business feedback, and deploying a scalable solution. As technology evolves, we can expect even more sophisticated and hyper-personalized shopping experiences, driving the future of AI-powered e-commerce. Thank you for taking the time to view my presentation on AI-powered personalized product recommendations for e-commerce. I appreciate your feedback and insights as part of this peer evaluation process. Your perspectives will help refine and strengthen this project. If you have any questions, comments, or suggestions, I'd love to hear them. Looking forward to your thoughts and learning from each of you. Thank you again for your time.